Okay, now, page 311
Hello?
talks about your inverse arc functions. Sine inverse, cosine inverse, tangent inverse. Okay? Now, if I were to solve this thing for x, what would I do?
Add 1 to both.
I'd add 1 to both sides.
So should we be writing it down, or is it?
Well, is it going to get in your head magically?
Yes.
You know how well that worked out for you whenever you didn't write anything down today I reviewed?
Divide by 2.
Static, get back to biting the butt. Now, divide both sides by 2. Now, I need to solve this thing for x, right? Well, am I allowed to divide by sine? No. No. Okay?
Multiply both.
I have to do the arc sine of both sides. So if I do the arc sine of both sides, x is going to be equal to sine inverse of 1/2. Now, according to page 311, the question I have to ask you, first of all, is 1/2 inside my domain? Well, what's the domain? The domain of the sine inverse is -1 is less than or equal to x, which is less than or equal to 1. Is 1/2 inside there? Yes, so that's a true statement, so it does work. Now the next thing is I need to look at the range. What is the range of the arc sine? Negative pi over 2 is less than or equal to x or y, which is less than or equal to pi over 2. Which means, what quadrants am I in? I am in quadrant 1 and in quadrant 4, right? Negative pi over 2 is right here. The positive pi over 2 is right here. Agree? So what this means is I'm looking for answers. I'm looking for angles that have a sine value of 1/2 that exists either in quadrant 1 or in quadrant 4. Do we get that? And the reason why I'm looking for those angles is because I chose to divide by the sine. I can't divide by sine, so I took the arc sine. You understand that? So what angle lies in quadrant 1 or 4 that has a sine of 1/2?
30. 60.
Is it 30 or 60? You were right the first time. I'm making sure that you understand.
Don't second guess me.
You have to second guess yourself because you have to know in your head that you're doing the right thing. For any of you. The hands of the clock is what we need to be considering here. 1, 2, 3, which means I'm looking for sine being 1/2. That's going to give me the lovely little angle of pi over 6. So x is going to be equal to pi over 6 degrees. Is that between negative pi over 2 and pi over 6? Yes, it is. So my answer to this is pi over 6. Okay? Now, why is the book contradictory on this? Because the book will say give me all the angles between 0 and 2 pi that have a sine of 1/2. It does not use the arc sine values. So therefore it jacks with your head. You get what I'm saying? So what it says here is it says, well, instead of doing just pi over 6, if it was between 0 to 2 pi, what are all the angles from 0 to 2 pi that have a sine value of 1/2? Well, what quadrants are sine positive? Quadrant 1 and quadrant 2 is where sine is positive. So what other angle between 0 and 2 pi, besides pi over 6, would have a sine value of 1/2? That's in quadrant 2. 5 pi over 6. However, does 5 pi over 6 technically work?
No.
Why? It's not the range of the arc sine. Do we understand that? Now, you understand why I'm saying this book is very contradictory. Because it wants you to apply the arc sine and the arc cosine and the arc tangent, but then it wants you to forget the restrictions on it. Well, I don't want you to forget the restrictions because that's like, it's like working and not getting paid. Nobody wants to work unless they get paid. So technically, if this says from 0 to 2 pi, they want these two answers. If it does not say from 0 to 2 pi, it wants you to apply the restrictions and give you the pi over 6 answer. Does everybody understand what I just said? Here we go. What do I do with this one?
Okay, I'll write it down. Root 2.
I have sine of x plus the square root of 2 is equal to negative sine of x.
Subtracting signs.
I'm going to add sine of x to both sides.
Why you adding?
Because I want to make this thing equal to 0.
Alright.
So I have 2 sine of x plus the square root of 2 is equal to 0.
Where?
I need to solve this thing for x. What do? So 2 sine of x is equal to negative square root of 2 over minus square root of 2. Right? Now what? Divide by 2. Okay, so my range, if I was between 0 to 2 pi, if I was between 0 and 2 pi, what would be all of my answers? This is saying it's looking for all the angles that what? Have a sine value of negative square root of 2 over 2, right? So where's sine negative at?
3, 4.
Sine is negative, and quads 3, and quad 4. So what two angles in quad 3 and 4 have a negative square root of 2 over 2 as their sine value?
4.
Okay, so what angles are going to give me
5, 5. Right.
I'm going to have 5 pi over 4, and I'm going to have 7 pi over 4. Well, how does he know that? Because he knows that a degree, an angle that has square root 2 over 2 in it has a denominator of 4, right? So I'm looking for the angles in quadrant 3 and quadrant 4 that have that level of value. Okay, well that's all the angles between 0 and 2 pi, correct? Now my question is if they didn't ask for all the angles from 0 to 2 pi, and instead they asked you to use the arc sine restrictions, my question is would both of these angles work? Would 5 pi over 4 and 7 pi over 4 work? Well, what's the domain restrictions? It has to be between negative 1 to 1. Is negative square root of 2 over 2 between negative 1 and 1? Sure it is. Okay, but what's the range restrictions? Whenever you use arc sine on page 311. Has to be between negative pi over 2 to pi over 2. If I plug either one of these answers in, does that make it a true statement? No, it makes it a false statement. More importantly, 5 pi over 4 is in quadrant 3, and 7 pi over 4 is in quadrant 4. Which one of those angles am I not allowed to be whenever I'm using my arc sine restrictions? Here's negative pi over 2, here's positive pi over 2, which means I'm in quads 1 and 4. Can I even be 5 pi over 4? No, which means this goes away completely. Then 7 pi over 4, is it in quadrant 4? Yes, it is in quadrant 4, but does that make it a true statement? Is negative pi over 2 less than or equal to 7 pi over 4, which is less than or equal to pi over 2? Why do I need to find a coterminal? I need to be in that range. 7 pi over 4 is the right angle, but it doesn't make it a true statement in the range. So what would make that a true statement? It would be actually taking 7 pi over 4 and subtracting the 8 pi over 4 to get negative pi over 4. This would be my answer. Do we understand that? That is exactly what your book does not do, and I really, really have a problem with that. Okay? They're asking for all the answers between 0 and 2 pi. That's fine and legit. You get 5 pi over 4 and 7 pi over 4. But if you are truly using your arc sine values, which means you have to take the arc sine of both sides, right? You have to ask yourself two questions. Is negative square root of 2 over 2 in your domain? And yes, it is. And then what is my range? My range is from negative pi over 2 to pi over 2, which is why I have to find my coterminal, which is the negative pi over 4. Do we understand that value there and why we have that answer? Are we good with that? Some of you are zoning out on me. Next. Okay, I need to solve this thing for x. In order to solve this thing for x, I have to first what? I need to bring everything over and make it equal to 0. So I have the cotangent of x times the cosine squared of x minus 2 cotangent of x is equal to 0. Now what? I don't have any. You and me will pretty sure. You record that. Can you take an x out? Okay, why do I just say go fish in the dark? If I say go fish, what's that mean mathematically? If I say fish it out, you need to take out a common factor. The greatest common factor in this example is going to be a cotangent of x. If I pull out a cotangent of x, I'm going to be left with what? Cosine squared of x minus 2 is equal to 0. Yes? Don't write this down, but pretend it's there. I took out the trig, didn't I? If I take the trig out of this problem, what is your Algebra 2 brain thinking you should do at this moment? I want you to distribute. I want you to solve. How would you solve? If I say solve this thing, I didn't say make it more complicated by distributing the x, then you're going to go right back to what we had at the beginning. I said solve for x. So what does your Algebra 2 brain tell you to do here?
It's going to help you distribute.
How are they attached?
Multiplication.
Is that equal to 0 already? So if I can do this in Algebra 2, what can I do with the trig? I can do the exact same thing. So what I'm going to have here is going to be the cotangent of x is equal to 0, and the cosine squared of x minus 2 is equal to 0. Do you know why you guys struggle and freak out? Because you refuse to remember the stuff you learned in Algebra 2.
I don't think you should.
But you learned something. Thank you. So now, x is going to be equal to the cotangent inverse of 0. Okay. Well, first of all, the domain, even if you don't remember, the domain is always going to be from negative pi. Look on page 311. Page 311 right now. What is tangent going to be? Negative infinity to positive infinity. Well, we automatically know this is the domain. Now, if you look at the tangent, the range of the tangent is from negative pi over 2 to pi over 2. Well, the range of the cotangent is from 0 to pi. Okay? So now I want to know all the angles from 0 to pi that give me a 0 as my cotangent. Now let's think about that a minute. On your unit circle, what does the x value relate to? Cosine. Right. So what does the y value relate to? The sine. Now what is my definition of cotangent? You know it's not, so that's tangent. What's cotangent? Cosine over sine. So that means I'm looking for my x value over my y value. I need my x value over my y value to equal 0. So what does x have to be in this case? X is cosine. Yes. Guys. Are we listening? I need my fraction, when I simplify it, to equal 0. Well, the only way I have zeros, where's 0 found on my unit circle? On your axes, right? 0 degrees, 90 degrees, 180 degrees, and 270 degrees, right? There's zeros in those ordered pairs. Now, which one of those am I going to be looking for? Cotangent is x over y. So does x have to be 0 or does y have to be 0? Why does x have to be 0? 0 divided by jump is equal to 0. The jump divided by 0 equals what? Undefined. I didn't ask for undefined, I asked for 0, which means my numerator has to be 0. Do we all understand that, yes or no? That's a long time to get that. So now, that means I'm in quadrants 1 and 0, 1 and 2, sorry. I'm in quadrants 1 and 2. What angle between 1 and 2 has a cotangent of 0? It's either 0, 90, or 180. Which one is it? Which angle, 0, 90, or 180, has an x-coordinate being 0? 90. Are we all certain of that? So x in this case is going to be pi over 2. Do we all get that yet? No. I pray that you do. Because if I go back over that, whew. Go to the next one. I have to solve this cosine squared minus x minus 2 is equal to 0. What do I do? Add 2. Cosine squared of x is equal to 2. Square root. Cosine of x is equal to plus or minus the square root of 2. Is square root of 2 in the range from -1 to 1? Did anybody here know that decimal memorized? Is the square root of 2 in between -1 and 1? It is 1.4, Mr. Precision Machining. Your decimals helped you just now. Okay? Yes, so this cosine of x is actually plus or minus 1.4. -1 is less than or equal to 1.4, which is less than or equal to 1. Is that a true or a false statement? That's a false statement, which means 1.4 is not in my domain. So can I do this side? I can't do it because it's not in my domain. You can understand that. So this whole side is null and void. So what is my only answer? Pi over 2. Do we understand that? That's my only answer. Do we get that? Oh boy. Okay. Tonight's homework is written A1 through 16 all. Now, you have to read the instructions. I can't say this any clearer than that. If you skip the instructions, you're going to jack up your whole problem. Because the problem will ask, give me all the answers between 0 and 2 pi, which are they ask you for restrictions then? If the directions say, give me the answers from 0 to 2 pi, are they looking for any restricted answers? No, they're not. Okay? All right, number 1 in the textbook, what's it say? It says verify that each x value is a solution of the equation. There's 2 ways you can do this. When it says to verify, you can plug and chug and make plug the inside equal to the right hand side and determine if it's true or false. You with me? How many people in here love to plug and chug? You love to plug and chug. You go until your hearts just make you ecstatic. I don't even care. Just have at it. Okay? But then there's going to be other people who are going to say, I am not plugging and chugging to save my soul because I want to make sure I get one answer and only one answer and make it really easy. So what if I just solve this thing for x? I can figure out the answer and then say, is that an answer? Nope. Is that an answer? Nope. Or yes, it is. So I have 2 cosine of x is equal to 1. Cosine of x is equal to 1/2. Cosine x is equal to arc cosine of 1/2. Is 1/2 in my domain? -1 to 1. Is it? Yes. My range for cosine. What's my range for cosine? Page 311. What's my range for cosine? Arc cosine, page 311. 0 to pi. So this says that my range is going to be from 0 to pi. So what angles from 0 to pi have a lovely little cosine of 1/2? Cosine x or y? X is your cosine value. So which cosine value or angle has a cosine of 1/2? Pi over 6. Which is in quad 1. Do I have an angle in quad 2 that's positive 1/2? Well, no, right? Why no? Because it's negative, right? Well, in quadrant 2, it's negative angle, so that's not going to work. How about in quadrant 3? Is cosine positive or negative in quadrant 3? It's negative, so that's not going to work. And in quadrant 4, what would be my possible value if I'd be in quadrant 4? My unit circle is kind of important. Has to have the denominator 6, right? 11 pi over 6. Okay, well is that going to work? Why? It's not in my range. Okay, so we know none of these are going to work. The only one that's going to work is this. So if we look at our answers, number 1 says the cosine is pi over 3. Ah, man. Crap. Yeah.
I said 3, and you made me feel dumb.
I heard 6 and I heard 3 and I chose the wrong one. I apologize for that. Which means in quadrant 4, what would that be? In quadrant 4. Well, 2 pi over, 2 pi needs to have a denominator of 3, so that's going to be 6 pi over 3, so what's that one going to be on there? 5 pi over 3. Okay, so this is actually letter A, and this is letter B. Okay, that's letter B. That's their asking us. Letter A was pi over 3, letter B was 5 pi over 3. That's why that comes up. Okay, I apologize for that.
So either we can do the math,
Or you
we
can plug and chug. No.
yes or no.
I'm going to show you the plug and chug method. We know clearly that it's going to be pi over 3. Because that, according to the answer clock 1, 2, 3. Right? If we plug and chug this, my original
You can't put
problem.
it in a computer or calculator?
No, I don't want you to put it in the calculator.
both?
You use your brain. 2 times the cosine of 5 pi over 3. What is the cosine of 5 pi over 3? Well, that's in quadrant 4, and the cosine in quadrant 4 is that positive or negative? Positive. So this would be 2 times the cosine of what? 1/2. So that's 1 minus 1. That gives you 0. 0 equals 0.
I don't like that.
Is it a true or false statement? It is still a true statement because the cosine at 5 pi over 3 is positive. So this could still work. Okay? Now, that's going right back to the whole concept of what? It's giving you all the numbers between 0 and 2 pi, which is shady. It's not doing that little restriction thing. Because we still have to learn, we need to understand why. You have to understand why 5 pi over 3 actually works.
For every time I take a shower, I gotta know this. Just saying.
Let's do another one in that section so that you guys understand.
Number 2.
What's another one in that section?
Number 2.
16.
Oh.
Number 6, Emily. Could you read me that problem?
Secant the fourth of x minus 3, secant squared of x minus 4 is 0.
Okay. Take the secants out of there. Pretend you have this. Pretend you have this. This is an algebra 2 problem. What would you do if you had that in algebra 2?
Oh, that's so cute.
Yeah. Whenever you say grouping,
Binomial.
so you're meaning 2 sets of parentheses. That's 2 binomials.
We call it the
Factoring into binomials. Whenever you say grouping, grouping means that you're actually putting parentheses around 2 and there's 4 terms there. Okay. Now, how would you break up x to the 4th easily? Factors of 4 that are going to give me what? I need factors of 4 that are going to subtract to give me negative 3. What is that going to be? Minus 4, positive 1. Now put the trig back in. Put the trig back in. So that's going to be your secant squared of x minus 4. And then the secant squared of x plus 1 is equal to 0. So they're both equal to 0. Factors of 4 that are going to give you negative 3. So if I take the square root of both sides, it's going to give me plus or minus 2, right? If I take the square root of both sides over here, that's going to give me plus or minus the square root of negative 1. What's the square root of negative 1? Imaginary. So do I even acknowledge that part anymore? No, because that's not real. It's not real, right? Secant. Well, let's think about secant. What do I know about secant?
Cosine.
It's 1 over cosine, which means I actually am looking for what on the unit circle. If secant of x is going to be equal to plus or minus 2, then what would cosine be? Plus or minus 1/2, right? Did you see where my brain went with that? So what am I looking for on my unit circle? All the angles that have a positive and a negative what? Cosine of 1/2. Do we understand that? If secant of x is equal to plus or minus 2, then that means cosine of x is equal to plus or minus 1/2. Can we get that, yes or no? So what are all the angles that have plus or minus 1/2? Well, we already know it can be pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Those are all your angles. Now, what does it ask you to do? Verify that each one's a solution. So if you're looking down here, it wants to know is 2 pi over 3 and 5 pi over 3 a solution? It's a possible solution. It's a possible solution. So yes, they would work. Do we understand that, yes or no? According to this, yes, those are both solutions. This is letter A, this is letter B. If you don't want to do it like this, then what could you do? Plug and chug and prove it that 0 equals 0. They both work, yeah. They both work. (13) 4 cosine squared minus 1. What would you do here? Add 1. Then 1. Divided by 4. Then 1. Take the square root. You see how I get the square root of the side on the bottom there? Cosine of x is equal to plus or minus 1 over 2. So now, read the directions. Is it asking for you to use the restrictions or not? It just says to solve. And this is where I have a problem with this. What are all the angles that have a positive and negative cosine? We just talked about that, cosine of 1/2. What is it? Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Now, the book is going to do something that's a little bit different. If I'm at pi over 3, and I add pi units to that, where does that put me? Four pi over 3, right? If I'm at 2 pi over 3, and I add pi units to that, where does that put me at? 5 pi over 3. Do we see that? The book does something a little bit different, and what it says is it's going to take this is going to say, well, x is going to be equal to pi over 3 plus pi k, and
Yes, I know
x is
that.
going to be equal to 2 pi over 3 plus pi k. What that means is they're adding pi units every time to k is the number of revolutions around the circle. I'm okay with this right here.